All right, good morning, good afternoon, or good evening, everybody. Today we're going to talk about independent and dependent probability. So, as with everything that we've talked about in probability, our vocab is vital in order for us to understand what we're talking about. So, what does it mean to be independent or dependent probability? Independent probability is when the outcome of one event does not impact the outcome of the second event. So, that keyword not. And so what this would be the same as saying, like, if I were to roll a die or flip a coin. What I get when I roll the die should not have any impact on what I get when I flip the coin. Likewise, what I get if I were to flip the coin first would not affect what I get when I roll the die. So those two things would be considered independent of each other because they're not going to have any impact on the outcome of the second event. And so we can determine our independent probability by multiplying the probability of each event happening, which is the probability of A and B happening. So if I were to go back to the rolling the die and flipping a coin example, if I wanted to know, let's say, the probability of rolling a 5 and landing on tails. So I would do the probability of rolling a 5, which is the 1 in 6, right? There's one side that's a 5 on 6-sided die, times the probability of landing on tails, which is 1 out of 2. And so multiplying my probabilities, I multiply across the top, 1 times 1 giving us 1, and multiply across the bottom, 6 times 2 giving us 12. So the probability of that second event is not impacted by the probability of the first event. They are independent of each other. Dependent probability is when the outcome of one event impacts the outcome of another. So it depends on the other event. So this can be determined by multiplying the probability of each event, but event B must have event A removed. So for example, let's say I had marbles in a bag, right? So here's my bag. We can use our imagination here. So I have 1, 2, 3 red marbles, and then I'll have 1, 2 blue marbles. So my probability of picking a red and another red. So if I were to reach into the bag, pull out a red, and then reach into the bag and pull out another red. So my probability of picking the red the first time is 3 out of 5. Now I have to calculate the probability of getting a red after I've already taken one out of the bag. So what's going to happen here is if I've already taken one out, this red no longer exists. So now my probability of selecting a red on the second pull is going to be 2 out of 4. So we have to be really careful here that we have that dependent event, right? It's going to depend because I've already taken one out. So it's going to change how many reds are available, and it's going to change how many marbles are available in the bag to begin with. So again, I can multiply across the top here. So I have 3 times 2 giving us 6, and then I have 5 times 4 giving us 20. Now, we could leave our probability as 6 out of 20, or we could simplify this. Both the top and the bottom are divisible by 2, so I'm going to divide top and bottom by 2. 6 divided by 2 giving us 3, and 20 divided by 2 giving us 10. So I have my probability of 3 out of 10. So independent probability, they don't depend on each other, and we just multiply those two probabilities. Dependent probability, they do depend on the other, and so the outcome of the second event will depend on the outcome of the first event. So first thing we should really do is make sure we understand how to determine if something is independent or dependent, because that's going to change how we calculate our probabilities. So we're going to read each situation below and determine if it is an independent or a dependent event. So the first one, flipping 2 coins results in one landing on heads and one landing on tails. So imagine you were to flip 2 coins. Put yourself in that situation. Does what you get on the first coin affect what you get on the second coin? Nope. So those two things are independent. My big handwriting. All right, number 2. The captain of the football team is selected, and then the co-captain is selected. So again, put yourself in the position of the coach here. So you have a selection of people that you're going to pick to be either captain or co-captain. So the probability of selecting someone to be captain, and we're going to assume that there's some randomness here, not necessarily based on like how long they've been on the team or skill level, but if we were to just randomly pick a player out of a hat. So if we were to just randomly pick the captain, we would pick, one out of however many people we're picking from. And then once that person is selected to pick the co-captain, we're now going to have one less person to select from. So the result we get on the first selection for the captain will affect our selection of co-captain, right? That person can't be selected for both. So these two events would be considered dependent. All right, number 3, you draw a joker from a deck of cards and then you draw an ace. So if I were to take the joker out of the card deck from that first draw, and I'm not putting it back in because they don't tell us. So we're just pulling a joker and then we pull an ace. So to pull the ace, we now have one less card since we've already taken out the joker. So because that will change how many we can select from, that will change our probability of drawing the ace. And these two things are considered dependent. If you draw a queen from a deck of cards, replace it, and then draw a 10. So let's think about this. My probability of drawing the queen is 1 out of 52 cards. And then I put it back in. So then I now want to select another card, and I still have that 52 cards in the deck. So that's not going to affect our probability when we draw a 10. So these two things would be considered independent. All right, number 5. A coin is flipped and a number cube is rolled, and so that's a die. So if I flip a coin and then roll a die, does the outcome of the coin flip have an impact on the die roll? Nope, we saw this before. These two are independent. So if the outcome for the second probability is not affected by the first probability, then they are independent. If they are impacted, then it is dependent. All right, so for our next example here, we're going to calculate independent probabilities. So this one's really nice because they're already telling us that they're going to be independent. So if we remember, this is the probability of event A times the probability of event B. So Neil goes to the pet shop and selects a treat for his dog. He chooses one, returns it to the bunch, and then chooses another. We want to know what is the probability that Neil selects a bone and then a collar. So in this case, when we select the probability of getting a bone, we have to think about how many bones are there out of how many total items. So there are 3 bones out of 6 total items. And I can leave this as 3 over 6. I could simplify it to 1/2. Right now, because he puts the bone back, we still are looking at the same selection of items. So that's not going to change our probability of then selecting a collar because he returned the bone back to the pile. So now our probability of selecting a collar is how many are there out of how many total items. So there is 1 collar out of our same 6 total items still. So the probability of selecting a bone is 3/6 times the probability of selecting a collar is 1/6. We multiply across the numerator and then we multiply across the denominator. 3 times 1 giving us 3, 6 times 6 giving us 36. Now that can be simplified by dividing both the top and the bottom by 3 to get 1/12. So our probability that he selects the bone, returns it, and then selects a collar is 1/12. Now for our next one, we want to calculate dependent probability. So again, the heading is really nice because it's giving us a hint here. So Neil goes to the pet shop again and selects a treat for his dog. He chooses one and then chooses another. What is the probability that he selects a bone and then a ball? So he is going to pick the bone, keep it, and then pick the ball. So we're going to see how that's going to impact our second probability. So what's the probability that he selects the bone first, right? So let's look at it. It's again, how many bones out of how many total items? So our probability here is going to be 3 out of 7. There's 3 bones and 7 items. All right, then we want the probability now that he would pick a ball. So where this can get tricky is that he's already selected a bone, so that's no longer an option for us to pick from. So how many balls are there? There are 2 to choose from. Out of now how many items? 1, 2, 3, 4, 5, 6 items now, right? Because we've removed that bone. So our probability of our first event, A, is 3/7, and then our probability of event B, after A has already happened, or minus A, right, taking out that bone, is 2/6. So we can multiply across the top, the numerators, 3 times 2 giving us 6, multiply across the bottom, the denominator, 7 times 6 giving us 42. And we should look to see if we can simplify. These are both divisible by 6, and so we get a final answer of 1/7. So for that independent, we just multiply our 2 probabilities. For dependent, we have to think a little bit more about what's the probability on that second outcome. All right, so let's try some more. We have 2 more examples. So number 1, Henry has a fair number pyramid with 4 faces and a spinner with 3 equal-sized color sections. So we're told it's a fair number pyramid, meaning that the 4 faces, 1, 2, 3, and 4, can come out in equal probabilities, and equal-sized color sections on the spinner, telling us again the red, blue, and green, can come out in equal probabilities. So we want to know what the possible outcomes for each are shown below. So we see that for the number pyramid, we can get 1 through 4. For the spinner, we can get red, blue, and green. So the question is, what is the probability that the number pyramid will land on 3 and the spinner will stop on blue? So in order to figure out these 2 events happening together, I have to first decide, are they independent or dependent of each other? So I ask myself, does what I get on the number pyramid affect what I get on the spinner? So think about it. If I were to like roll a 4-sided number pyramid and then flick the spinner, are they gonna have anything to do with each other? So are they independent or dependent? These 2 events would be considered independent because what I get on the number pyramid does not change what I'm gonna get on the spinner, right? They're 2 totally separate items. So our probability is probability of event A times the probability of event B. And in this case, that's the probability that we land on a 3 times the probability that we land on blue. Okay, so what's the probability that I land on 3? Well, there is 1 3 out of 1, 2, 3, 4 sides. What's the probability we land on blue? Well, there is 1 blue side out of 1, 2, 3 total outcomes. All right, so now we're ready to multiply our probabilities. 1/4 times 1/3, multiplying across the top gives us 1, multiplying across the bottom gives us 12, and I look at my answer choices, that matches choice A. Number 2. You have a bag of marbles with 5 blue, 3 red, and 2 green marbles. You reach into the bag and select a marble. Then, without replacement, so we take the marble that we got and we keep it, we are going to then select another marble. So what's the probability of selecting 2 blue marbles in a row? So in this case, I have to again first decide, are they independent or dependent? So because I'm going to be selecting that blue marble first, will that change my probability of selecting the blue marble second? Totally. So these 2 things are going to be considered dependent. And so my probability in this case is the probability of A times the probability of B after A happened. So we're going to look at the probability that we get a blue marble times the probability that we get another blue marble. All right, so what's the probability that we reach into this bag and select a blue marble? So again, I look at how many blue I have out of how many total. So I have 5 blue out of 5, 6, 7, 8, 9, 10 total marbles, right? So I'm just adding up the 5 blue, 3 green, and 3 red and 2 green. Now, if I have selected a blue marble already, what that means is now I only have 4 blue marbles in the bag. So my probability of selecting another blue at this point is going to be 4 out of how many marbles? Well, there's only 9 left in the bag. So that does change our probability here. So we multiply across the top to get 20, multiply across the bottom to get 90. This simplifies pretty nicely because we know that if we have 0 and 0, right, if we have multiples of 10, we can cancel those out to get 2 out of 9. Right, so again, the really important thing here is paying attention to, is the event independent or dependent? Because that's going to change our probability. The best advice that we can give you is to really put yourself in the situation, right? Imagine you have this bag of marbles. Imagine you are reaching in. And one of the good things about this is that you're always going to be successful in probability. So you do reach in, you do grab that blue marble. Then the second time you do reach in and you do grab another blue marble, right? You can think about those probabilities. Imagine actually doing that activity. So we really want to pay attention to, again, if they depend on each other or not, because that will change how we calculate that second probability. But either way, we're multiplying the probability of the first event times the probability of the second event. It's just a matter of whether or not that second event is impacted or dependent on the first event. Hope you guys enjoyed watching. Have a good one.